So it's 11 o'clock now, so we'll make a start. Hello everyone and welcome to today's webinar, Arcade in ArcGIS Expressions for Everyone. Thank you for joining us, and a little bit of housekeeping before we get started. This webinar is live, but it is being recorded and we'll share this recording with you afterwards. The follow-up email will also include links to some useful resources, and we'll be doing a Q&A at the end. So please open up Slido by either scanning the QR code on the screen or going to slido.com and entering our event code, and pop your questions in there throughout the webinar. We'll answer the questions in order of popularity, so please use the upvote function to vote for questions of interest. And there'll also be some polls available on Slido towards the end of the webinar, so you can leave some feedback for us too, which we'd greatly appreciate. I'm Catherine Clark, a senior consultant in the pre-sales team here at Esri UK, and I'm joined by three of my colleagues today, so I'll hand over to Isla.
Hi everyone, my name's Isla. I'm a graduate GIS consultant at Esri UK. I'll hand over to Dave.
Thanks, Isla. I'm Dave. I'm a GIS consultant in our education team, and I'll pass to Will.
Hello, I'm Will. I'm a software engineer in our professional services team.
Cool, thanks everyone. So on the agenda for today, we're going to start with the basics, looking at where you can get started with Arcade. I'll then be handing over to Isla, who will be teaching us some specific syntax, and Dave will be kicking off a series of live demos we've prepared for you to show you some of this theory in action. And our demos today are going to be focused on ArcGIS Online, but you can apply the same principles in ArcGIS Pro as well. And we'll finish off with our top tips and tricks before moving into the live Q&A at the end. So let's begin by thinking about what is Arcade. And this might be a recap for some of you who joined our previous webinar on Arcade last year. Arcade is a portable, lightweight expression language that you can use to create customized content within ArcGIS. But what does that actually mean? Well, the portable aspect is because it can be used in various places or environments across the system. So you can run it on a desktop application, i.e. within ArcGIS Pro, but also in a browser and in the ArcGIS mobile apps as well. It's lightweight because it has a relatively small number of functions, and we refer to it as an expression language because it runs small pieces of script within the context of another application. But focusing on the portable aspect of Arcade, where exactly can you use it across ArcGIS? And this is determined by the Arcade profiles. And these Arcade profiles also determine the rules for how an Arcade expression is evaluated and interpreted. And you can find the specific details about all the Arcade profiles in the documentation. So if I open that up quickly, I'm on the developers website, and on the homepage of Arcade, you'll see on the top right-hand side the Profiles tab. If I click into the profiles, you can see they're all listed there for me, from attribute rules to dashboards to field calculations. And if I open up the field calculation profile, you can see here I can see under context the products which implement this profile. So I can use it in Pro, Enterprise, Online, and the Maps SDKs for native apps. Further down the page, there's some information on variables and functions, and Isla will be telling us more about these in a bit. While I'm in the documentation, I just also wanted to point out the playground, which is a great place for testing code, experimenting with the syntax, and there's some suggestions that you can get started with, or you can browse all the functions available and start looking at different profiles as well. So that's a really useful resource to use. Now, switching back to my slides. Where's the best place to get started when you want to create a specific expression? And before you start writing any code, you need to determine what is the output that you're aiming for. Once you have this clear output in mind, the next step would then be to explore your data. Do you already have all the attribute information you need, or will you need to calculate new data? Or maybe you need to include data from multiple different sources. Once you know what data you have, this is then when you can start writing your expression. The next step then is to run this code, execute the expression, and review the output. Is it what you're expecting? Or if not, or if maybe you've received some errors, you may need to return to step 3 and review that expression you have written. So that's the workflow we'd suggest starting with. So now I'll pass over to Isla, who's going to take us through some more specifics about the syntax.
Thanks, Catherine. Okay, so in this section, I'm going to take you through the basics of the syntax used for arcade expressions. As you know by now, these are the blocks of code that make up arcade scripts, and they tell the computer or the ArcGIS system what to do. When we talk about syntax, we're talking about the specific language markers or formatting used within our expressions to give the computer instructions. Since the computer will read these instructions from top to bottom, it's important that you write your code in the order you want the computer to perform or run it in. If you know some JavaScript, then some parts of Arcade may feel familiar to you, but I'll go through the basics now so that we're all on the same page. Going forward, I've highlighted the code you can change to your own values in gray, and I've put the syntax you need to keep the same in bold green. Syntax that you can modify for your own expressions will be both highlighted gray and be in bold green. You can look at the guide in the top right corner if you'd like to refer back to this. I'll be going through a lot of information pretty quickly, but don't worry because you can always watch the recording back later if you want. If you're interested in finding out more about how to format your code, then have a look through the Arcade documentation, or check out the scripting style guide page that was written for Suite for ArcGIS, as this is also a helpful reference. Here's the example Arcade expression I'll be using to highlight the different parts of the syntax. It might look a bit overwhelming right now, but don't worry because we're going to break it down into all of its different parts soon. For context, this expression was written to calculate the tree density using points of tree inspections and polygons of campus areas. This expression is for the pop-up on the polygon area. Okay, without further ado, let's get stuck into the syntax. Comments are helpful notes that you add throughout your code to help others or your future self make sense of it. Anything marked as a comment will not be recognized as live code by the computer, so they can also be a useful way of marking sections of code when you're testing out different versions. You can make a single line comment by starting them with 2 forward slashes, or make a multi-line comment by marking the start and end with a forward slash and an asterisk. Taking a look at our example, you can see I've used both types of comments here, a multi-line comment at the beginning and single line comments to describe the different steps in my expression. You might want to reuse code to use again later in your expression, and you can do this through variables. These can be used to store single values, multiple values, or expressions, and they are defined by writing var, the variable name, and then generally followed by an equal sign and your variable values after. There are a couple different types of variables, global and local. Global variables can be defined once and then used throughout your code as much as you wish, while local variables are used in a very small part of your code and can't be used elsewhere, such as in a for loop. I won't be showing you this in action today, but it is good to be aware of the difference. Your variables are not case sensitive, but it is good practice to use camel case, where you capitalize all but the first word in your variable name to make your code easier to read. Looking at our example, you can see that we've started our expression live code with defining 2 variables, one for accessing the tree inspection point data and one for counting these trees in the campus areas. Later in the expression, I use another variable to calculate tree density. But how do we actually achieve this functionality? The key lies in functions. Now, functions are pre-written blocks of code that instruct the computer to perform specific actions. There are many of these available that you can use for formatting text, geometry, data, or more. You use functions by writing the function name and then using brackets. Some functions have specific formatting rules for what goes in their brackets, so check out the documentations if you're unsure of this. Note as well that function names have all words capitalized. You can use multiple functions together. Just make sure that the number of closing brackets at the end is accurate, and to keep in mind the order of your functions should be from inside out in the order you want the computer to read them in. To see how this works in practice, let's have a look at our example expression, where I've used a feature set by name function to access our tree data. On line 5, I've used two functions, the intersect function that finds the trees that intersect with campus areas, and the count function to count these trees in that order. On line 8, I've used two functions again, the area function to get the area of the campus in square kilometers, and the round function to round this number to 2 decimal places. You'll notice that we're using data from our map in our expression. This has been retrieved through profile variables, which are prefaced with the $sign. You can be quite specific and retrieve a field from your current working layer with the $sign feature full stop syntax, or you can use a feature set function such as feature set by name. You might be wondering what the difference is between a profile variable and the function in my second example here, so let's take a closer look. The function feature set by name has some specific formatting that you need to use within its brackets, and part of this is the profile variable called $map. You don't need to use a profile variable within a function, but what this function is doing is using the profile variable to access your map layers. You can see our profile variables in action in our script. They've been used a few different times in different functions to retrieve map layers or more specific features. You may also want to use text within your expressions. These need to be marked with double quotations. Make sure as well to add any formatting such as punctuation and spaces within the quotation marks to make sure your text reads nicely. Here's the text we have in our expressions. We've used it to specify the map layer we want in one of our functions, as well as the text within our return statement. Finally, while you're writing your expressions, there are a couple of different formatting guidelines you should also keep in mind. Semicolons tell the computer how to group different parts of your expressions and which parts to run together. It's good practice to put these at the end of expression parts such as returns or after you create new variables. If you need to join different parts of your expression together, then there are several ways to achieve this, but one way is putting an addition sign in between the parts you want to join together. You can see these in our example. Semicolons have been used at the end of our expression parts, and addition signs have been used in our return statement to join our sentence together. And there you have it, the basics of arcade syntax we use to build expressions. Now we're ready to put this into practice and write our own scripts. I'll hand over to David to get us started.
Perfect. For today's demos, we're taking on the role of an organisation with responsibility for managing trees across several sites in Exeter. We've been given a spreadsheet of historical tree inspections, including the date, condition and surveyor. The head of estates has told us that due to staff changes, a number of the trees are known to be overdue for inspection. They want us to provide details of trees requiring immediate inspection, a proactive management plan for the next year, and a mobile solution for field teams completing surveys in the future. So if I just share my screen and move us away from the slides, we can take a little look at that data. So the first thing I've done is to upload the spreadsheet into ArcGIS Online so I can see the data spatially. The data set contains the date that each tree was inspected, but it's missing some of the data that I'm interested in. So I'm going to use field calculations to fill those gaps. The first thing I want to know is how long it is since each tree was inspected. So I'm going to add a new field, inspection age. Because this field is going to contain a number of days, I'm going to use an integer. And in the calculate, I'm obviously going to be using Arcade. To help me out a little bit with this demo, I'm actually going to copy and paste the comments from my piece of script here into the box already, and then I'm going to fill in the blanks. You'll also notice that I've included all of the variable names just so that I don't get caught out by any typos later on. So the first thing I want to do is to define some variables that I'm going to reference later on. The first one of these is the variable inspection date, and I'm going to pull that from the survey date field in my existing data set. The second variable I define is today's date, And for that, I'm going to use a function, today. And that's all I need to do for the today function, nice and easy. The next step is a calculation to work out the difference between today's date and the date of the survey. And this time I'm going to use a function dateDiff. I popped that in the wrong box. Let me move that to the right place. There we go. Inspection age equals dateDiff, input date 1, date 2, and units. So input date 1 is going to be today date. Date 2, the inspection date. And the units here are going to be days. Note that the default for this is that the unit is milliseconds, not what I'm after. The final step is to return that inspection date, but rounded down to the nearest full day. To do that, I'm going to use the floor function. I'm just going to test that before I click run. And it looks like that's going to work for me. So I click OK and run that calculation. So now I have the inspection age in days. I know how long it was since each tree was surveyed. So I could just sort this and find the newest and oldest. So we can see that there are some trees that are very much overdue their inspections. But what I'm actually going to do is add another field and classify those. So my second field, inspection status, or let's just call that status, is going to be a string. And it's going to classify those inspections based on those which are overdue inspection, those which are pending inspection in the next 6 weeks, and those whose inspections are current. Again, back to calculate and another bit of Arcade. I'll bring in my comments so we can see what we're trying to achieve. And I've already calculated the number of days that's a year minus 6 weeks. So we can work out which of those pending inspections. And this time I'm going to use the when function. The when function works similarly to an if statement. So where the inspection age is greater than 365, we'll mark those as overdue. Where the inspection age is less than that, but greater than 323, we'll mark those as pending, and everything else we'll mark as current. And we'll return that status value. Again, I'm just going to click test to make sure that will work, and that looks like it's doing what I'm expecting. So again, I'll click OK. And we can see that my table is populated with those new classifications. If you prefer to work in ArcGIS Pro, you can achieve the same results by choosing Arcade in the Calculate Field tool. So those calculations have allowed me to identify the trees that need surveying as soon as possible. But field calculations are not dynamic. When I check back on those data next week, some more inspections might have become overdue, but that won't be reflected in the classification unless I run the calculations again. So instead, I'm going to apply the same calculations dynamically inside a web map. I've added the same data to my web map, and I'm going to use the same Arcade scripts, but this time I'm going to do it in the Styles menu. Rather than picking a field, I'll choose an expression. And I'm going to call this variable inspection status. Rather than running this in two expressions, I'm actually going to combine the two into one. So we can see the first part of my expression is calculating the number of days since each tree was last inspected, and the second part is performing that classification. Again, we're going to return the status. And there we have it. Because the output is a string, Smart Mapping has suggested I map using styles, which is what I want, but I can see that it's made some interesting color choices. For example, inspection current being red, not the most intuitive. So with a little bit of effort, I can symbolize this slightly differently. And I've even taken advantage of the new animation styles in ArcGIS Online to make those trees that are due an inspection really stand out. So going back to our objectives, I've identified the trees that need to be surveyed immediately, and I've built a map that can be used to work more proactively. Isla, over to you to take things a little further.
Thanks, Dave. Okay, so we have our web map configured, but our pop-ups are still looking a bit plain. So let's fix this with some Arcade. We've got our tree density expression ready to go, so let's use this first. I've added the campus area layer into my map, and I'm going to go into the pop-ups properties for this layer. I'm going to get rid of my fields list because I don't need this anymore. I'm going to add a new attribute expression. I'm going to rename this with tree density. And let's put in our expression from earlier. So just to recap, what this expression is doing is finding the trees that intersect with the campus areas and then calculating the density by dividing this by the area in square kilometers, which is then rounded to 2. And then finally, what's actually shown in the pop-ups is the text that says the density is this variable, which we calculated here, and then trees per square kilometer. So to add this into our pop-up, I need to add a new text section and then head to the fields list and add in our expression. So I click OK. We have our text here. Amazing. But I still think we could take this a little bit further. So let's go back to our attribute expression and edit this a little bit. I'll add in a new section before our return statement. And what I'm going to do is create a new variable and put an if-else statement in this. This is going to classify our values as high or low depending on the tree density that we calculated earlier. So if I remove this, and copy in this here, there we go. So we have our new variable called density classification. And what we're basically saying is that this exists, but depending on the outcome of our density calculation earlier, we're going to classify it as high or low and fill this variable with that answer. So if tree density is over 50, then we're going to fill this variable with the text that says high and the tree density value. But if it's any other value, so in this case below 50, then we're going to say it's low and then have the tree density value. So if I put this new variable into our return statement, then I can show you what this looks like now. Amazing, we've got this now figured and correct. But it still looks a little bit plain. I think we can make this look better. I'm going to show you this on our other layer in this web map, the tree inspection data. So again, I'm going to remove the fields list and I'm going to add in Arcade in a slightly different way. I'm going to add in an Arcade section. So if I just remove this, what I'm going to do is I'm going to classify the condition with different colors in my pop-up based on the condition value. So there's 3 values here, poor, moderate, and good, and I'm going to make them different colors depending on this answer. So because there's 3, I'm not going to use an if-else statement again. I'm actually going to use a when function. So if we create a new variable called score color, and then find the when function. You can see here that this is the format that this function is expecting. So expression, result, and then a default value. So that's important to keep in mind when I add in my expression content. Okay, so what's happening here is I'm saying for this field condition, if it equals poor, I want it to be this color. If it equals moderate, I want it to be this color. And if it equals good, I want it to be this color. And then I'm specifying that the default color is black. So even though we split up this function over several lines, the actual function format is remaining the same. Now our expression is basically done here, but I'm going to take it a little bit further by adding in some fun text. So if I add in a return text type, you can see here I've specified it as text, and I've got 2 backticks here, so these are not single quotes. I can add in some HTML and SCSS. This might look a little bit complicated, but don't worry. If you're interested in learning a bit more about how Arcade and HTML can be used hand in hand, then please check out the blog called Beginner Steps for Adding Color to Pop-ups with HTML, which we will send out in the follow-up email. But all I'm doing here is specifying that I want a border around my text. I have 2 different headings that have certain styles. So in this case, it has a background color, and I want the title to be in bold. And then I have the content within those sections. So you can see here that I've used a little bit of Arcade again just to get the score color, which we've defined here, and then the feature field condition and surveyor. So I click done. You can see here that we've added some really nice formatting. There's a border now, we've got 2 sections, and the text is dynamic depending on what the value actually is. So I'm really happy with that. I think this is ready to be sent out to Catherine, who will take it a little bit further.
Thanks, Isla. I will just share my screen. So I'm going to focus on getting our data ready for the field team to take out on site and start reviewing the trees. So I'm looking at the same data in Map Viewer that Dave and Isla have been working with. And what I'm going to do is start configuring a form. So I'm going to go to the Configure Editing button on the right-hand side for my trees layer and open up the form. Now I've already started getting this form ready to save a bit of time, and the easiest place to start with forms is to convert your pop-up, and this will bring all the fields that you have into your form. I've grouped my fields to make it a bit easier when my team start to come editing this data. And you can see I've added some read-only fields, for example, the tree ID. I don't want people to be able to edit that. If I just minimize that top section, I'm going to focus on the survey details, where I've got a field for surveyor and I've also got the survey date. Now you'll notice these have the calculated tag on them to show that these fields are being populated by an expression. And if I select that surveyor field on the right-hand side in properties, if you scroll down, you'll see the little cog at the bottom that allows you to add an expression. So let's open up that expression and I can show you what I've put for this one. So this field, I want the surveyor's name to be automatically populated. I don't want them to have to type it themselves or choose it from a list. And to do this, I've simply just used the getUser function. My next line of code a bit further down is to just specify that I want the full name. And if I run this code to check it, I can see that my full name gets returned for me. So this will be automatically populated based on whichever user is logged in. I'll just cancel that and I'll show you my survey date field. So again, I've written a very simple short expression to automatically populate today's date. And this is using the today function. I've defined an additional variable here, formatted date, to just make sure that it shows the date only rather than the time as well. And again, I can run this and I see that I get just the date outputted there for me. So if I come out of my form and I'll open up the edit pane. I can see that if I select a tree, I'll pick one on my map and open up the form. I can see those survey details. They're read-only fields, I can't edit them, and they've been automatically populated with my name and the survey date as well. So this is really saving time for editors, and you could use this form in the map viewer interface, which I'm in now, or you could use it in another app that has editing set up as well. But actually for this tree inspection data, the team are going to be out on site and they're going to be using field maps. So to configure my form for field maps, I can open up the field maps designer. Now, if you don't know where to find this, you can open up your app waffle on the top right-hand side and you can see there Field Maps Designer. So if I switch tabs, I'm now looking at my form from within the Field Maps Designer, and it's a very similar user interface. I can drag and drop new elements into my form if I want. I've got those same groups that you were just seeing in Map Viewer. They've been pulled through for me, so I don't need to do anything with that. But what I do want to do is complete this final element in site details. And here I want the site to be automatically populated. So when the team are inspecting a tree, they don't need to say what site they're working at. This will be automatically populated based on an intersect. And again, I do the same thing, scrolling down in the properties to the calculated expression section, and I can click to add a new expression. I'll give this a name at the top, site intersect, and I'm going to copy and paste some code in to show you. So it's a bit of a longer expression this time, but it's still quite simple when we break it down. The first thing I'm doing is defining a variable site boundaries, and I'm using the feature set by name function to look in my map for the site boundary layer, and specifically the site name field is what I'm interested in. I then need to define an additional variable, feature geometry, and this uses the geometry function to get the location of the current feature, so the location of the tree in this example. I can now do the intersect between these two features, so another variable, intersected site, and I use the function intersects. Now the final bit in my code is an if-else statement to say if the count of the intersected site, which is my intersect just above, is greater than 0, so i.e. there is a site that it's intersected with, then return the site name. But if there's not, then I return this text, no intersecting polygon. And again, I can run this code to check it's working as expected, and I can see the text that return is St. Luke's, which is the site that I've been using in this demo. So I know that's working okay. So now when the field team go out on site, they open up their Field Maps app and edit this data. These fields will be automatically populated for them, speeding up that data capture. So that brings us to the end of today's live demos. So just to summarize, you saw Dave added some new fields to the original data and then used those same expressions dynamically for the tree symbology in a web map to identify those overdue inspections. Isla then took us through how to add Arcade to our pop-ups, adding that additional new information on tree density per site to aid the management of our campuses. And finally, I showed how Arcade can be used within forms to automate some data capture for the field team. So we'll just finish off with some tips and tricks before we head into the Q&A. And these are just 4 key things we think is worthwhile for you to remember. Firstly, always start by thinking about what output you want before writing any code. So think back to that workflow I showed at the start, determine your output, explore your data, and then begin writing your expression. Secondly, if you're looking for a place just to test ideas, then there's that Arcade playground in the documentation. And thirdly, we'd recommend keeping a code snippet library. It's really easy to reuse code between different projects with just a few small changes, and you could also choose to maintain this library as a team to share ideas with each other. And finally, there's loads of blogs and forums available online which contain a lot of sample code that you can use as a guide for your own work. So take a look at them, and there'll be some in the follow-up email as well. So hopefully a lot of you are already registered to join us on the 13th of May at our annual conference in London. And the in-person registrations are now full, but you can still sign up for the live stream using the QR code on the screen there. And our next webinar will be on June the 19th, and this will be our ArcGIS update for summer. So make sure you have that in your diary, and you can sign up on the website as usual. So that brings us to the Q&A. If you've got any more questions, please add them and continue to use the upvote feature. So I'll kick us off with the most upvoted question, which is about when will Experience Builder support arcade expressions? Hopefully some of you have seen the answer that's been added to that question, but we're expecting Experience Builder support arcade in Q2 of this year in ArcGIS Online and Enterprise version 12.0. And Claudia's added the link there to the Experience Builder roadmap, and we'd recommend just keeping an eye on that for any updates. So the next question down, I think, Dave, do you want to take that one?
Yes, so it's not something that's on the roadmap, but there is quite a lengthy post on this on the Esri community site. I popped the link in response to the question on Slido. So it's a relatively, it's kind of sort of dates to 2020 or May 2022, so it's been around for a little while as a suggestion. It's marked as under consideration, so that means that it could happen, but it's not on any roadmap yet. But if you want to upvote that suggestion, you can hopefully kind of drive the direction of that roadmap to maybe pull that functionality into ArcGIS Online. So not at the moment, not on any current roadmap, but head to community to try and influence and push that forwards onto the roadmap. Is probably the best answer to that one.
Thanks, Dave. I'll just mark that one as answered. So our next question is, can I reuse the same arcade code across multiple apps for consistency by referencing the code rather than having to copy and paste into each app? So I guess it does depend what app you're using, but in that forms example I just showed, that would pull through to another app, that arcade in the form, but it does depend on the arcade profiles. So we'd recommend checking the documentation always. And Will, you've added some extra comments on that one if you wanted to add anything.
Yeah, I was just going to say it is useful to build a code library, as we talked about, and I've added a few tips there around making code reusable. So this just avoids hard coding values that you might change, and just sort of centralizing things so that you can easily copy and paste your logic over and just change the minimum amount of different variables to make code reusable. So it's a lot of the same practices as just proper and good code management.
Cool, thank you, Will. I'll mark that one as answered. So there is a question there on can you interact with your own data in the playground, which I showed at the start. So you can't interact with your own data, but if you take a look at the suggestions, there are 2 sample data sets that they reference, so you can play around using a data set, and then you obviously just need to switch the dataset ID and things like that if you want to use it in your own work. So I'll mark that one as answered. Dave, you have got a question. Could we use Arcade to update the symbology dynamically, e.g. to RAG the data based on different metrics and update the symbology based on the metric selected?
So I think kind of understanding this question, I think the answer is yes, and I think it's kind of pretty close to what we did in that second demo that I did, where we kind of brought those tree sort of tree inspection ages into the map viewer, and inside the map viewer we used essentially a little script there that ragged them based on a single metric, so in that case date, but it's just down to the complexity of your script really to kind of choose the metrics that you need, or the right combination of metrics if you're using kind of a multifactorial way of classifying them. And then as those metrics change, the symbology will update based on those kind of dynamic changes to that data. So just like in that map that we created in that kind of second demo, if we were to go back to that in a week's time, those trees that were currently maybe pending and might have turned overdue would reflect in that symbology.
Cool, thank you, Dave. I'll just mark that one as answered. Will, can we go to you for any plans to allow Arcade functions to trigger on the fly, i.e. without a user having to access a form, e.g. so if a point was moved, a field could update?
Yeah, I think this really depends on the context as to where the arcade's being used. So Arcade will fire depending on where and when it's being where and how it's being configured. So in the chat there, I just talked about how in Suite this can really depend on just the configuration of where it's being used. So the user may edit an attribute, and that will then fire the attribute validation script that's using the arcade. Or equally in dashboards, you could set it so that it's using the selection of a feature layer, so that the arcade is then based upon that. So I think the answer really is where is it being used? I think the question relates to field maps, so I can get back to you on that. But yeah, just a bit more information on that might be useful.
Cool, thanks, Will. And could we stick with you and go for does the length or complexity of the arcade impact the performance of mobile apps like Suite and field maps?
Yeah, I would say the length not so much, as long as it's doing lightweight sort of operations and functions. I think the performance really gets hindered by where you're sort of using excessive complex functions, like querying operations are going to take a bit longer to resolve, as well as just sort of common sense things like, are you trying to process hundreds of thousands of features? So I've added a few sort of tips to the comment there, just talking about doing things early. So if you are defining feature sets or filtering information, try and do that early so that it has as much time to resolve, and you'll sort of see some performance benefits to that.
Cool, thank you, Will. And then just mark that one as answered. The top question at the moment, any plans to allow Arcade to auto-generate features such as buffers? So if a user adds a feature of a certain type, a buffer could be created of a certain size. So Will added an answer to that, that you can just create a variable for the buffer size, then write a condition that assigns a specific value to the variable for each feature type and pass it into the buffer function. So yes, that is possible. Just looking at the list, we're getting lots of questions and just a couple of minutes left. Isla, do you want to take any of those questions?
I can answer the questions about the pop-ups. So can Arcade be used to modify pop-ups for hosted tile imagery layers in ArcGIS Online? The answer is no, you need to have feature layers. This will allow you to interact with your data, whereas hosted tile imagery layers are quite a static view. And then the other question, if I find it, is can Arcade be used to calculate areas from other layers and then be shown up in a pop-up? Yes, absolutely. So that's what I'm doing with the tree density calculation. So all I'm using is using the feature set by name function to get the layer from elsewhere in my map, and then I'm using the area function to get the area.
Perfect, thank you, Isla. So sorry we haven't been able to get to everyone's question. We've had loads of questions in there, but please do take a look at the resources that we share in the follow-up email, and the documentation is always a great place to look for finding out specifics. So yeah, I'll just leave it as that, and thank you all for joining, and hope to see some of you at the conference and in our future webinars. Goodbye for now.